Introduction to C# programming language. In this section, I'm going to be introducing you to the theoretical backgrounds of C# programming. So I would advise you to keep an open mind and just go through. This is going to give you the solid foundation that you need for the what lies ahead by the time we start coding. And then by the time we start coding, you can always come back here to recheck some of these theories, some of these foundations. So let's begin. Now C# written as C# is a modern language. It's very modern, elegant language, object-oriented, component-oriented programming language, and it's type-safe. So it's modern, it's built with the modern trends in mind. And then it's object-oriented. So the concept of object-oriented programming is this kind of programming paradigm that relies on the concept of objects and classes to structure a program to write piece of reusable components, piece of reusable codes, right? So that's a bit of what object-oriented programming is. Concepts, stuff are built in objects, and so you can easily describe anything, if they are objects. All right. And then beyond being object-oriented programming, C# is equally component-oriented. So component-oriented programming in the sense that stuff can be built in components, and these components can be exposed to other components so that they can be reused in other components. So this will enforce a concept in programming that we call dry. So the concept of dry is don't repeat yourself. So if you have built it in a component, just expose it so that other components can use it. So C# supports that. C# is not alone in this. There are a couple of other languages that support that are component oriented these days. Yeah, so C# is type safe, is strictly typed. Yeah, so there's no misassignment or malassignment of values to wrong type. So if you're coming from a background of a loosely typed programming language where you can assign stuff anyhow, so you can't do that here. So if you initiate a variable, say for instance we call it a string, it is compulsory that what you're assigning to that variable must be a string. So there's a type check. There's a type check and checks and ensure that you're not abusing or misusing types and vis-a-vis the value that you're assigning to them. So that's a bit of the definition at the surface what a C# is. Moving on now. So as a developer, when you're learning a new language, what you want to ask yourself is the kind of power this language gives you. You want to know before you have a deep dive. You want to be sure that knowing this language, you'll be able to do a lot. So I can assure you the C# enable developer build all sort of secured, robust application. So if you are looking at building a complex functional web application, you are looking at, for instance, a Facebook app. You want to build something like a Facebook, or you something like as complex as a Gmail or Google and all of that. Just name it. You are in line. C# is here for you. You can use C# to build it. Of course, not just using C# alone. C# along with other web technology, HTML, and all of that to build that. So you can use C# to build a complex, highly complex web application. Then desktop application, C# is a king when it comes to desktop. You can build, all sorts of complex desktop applications using C#. Okay, so if you're looking at console application as well, if you want to build an application that runs within pretty much like a command line interface where there's no GUI per se, so you can use C# to build such, like a network app and all of that. So you can use C# to build it. And then if you're looking at the modern trend of technology, you're looking at, okay, what is trending now is mobile application. Knowing C#, can I build a mobile application? For sure, yeah. In fact, C# gives a lot of power because you use C# to build the front end part of the mobile application, and also use C# to build the web API part. So you just use that with, you know, XML, and then you're fine. So there's this Xamarin framework that enables you to build, you know, in fact, you know, an hybrid kind of native hybrid application that runs on Android and iOS. You know, and if you use what we call Xamarin Form, you know, you can use the same code here on Android and iOS. So it gives you a lot of power. Now, if you're looking at, okay, what about artificial intelligence, machine learning, and all whatnot? All this you can use C#. C# is highly relevant in all these fields. You know, so C# gives you a lot of power, and I tell you, a lot of power. Now, a bit of history to what is C#. I want to know the history of C#. C# it belongs in the family of C, so that's where it has its roots. So if a C or C++ or Java or JavaScript developer, you know, you find C# a lot interesting, and it's going to be immediately familiar to you. Even having known C# that much, you'll be able to read the codes and understand what is being written. So C# is pretty elegant. So when we compare C# to C, C++, and even Java, C# is pretty elegant, a neat, very clean language, right? So it is. Now moving on, C#, we said C# runs within a .NET framework. So what is .NET architectures? I want to know. So a .NET framework is pretty much a virtual execution system called Common Language Runtime. You know, so the Common Language Runtime is a vision of Microsoft that, you know, multiple languages can be written to build components, to build programs, and then all these can then run on multiple platforms without having to build specifically for each architectures of this platform. You know, so let's say within the .NET framework, it's not only C# that is in there. We have VB.NET, you know, you have JavaScript, you have other languages there like that. So when you use all this language and use your language of choice to build whatever it is you want to build, you know, there should be a common, you know, interface or common runtime for all this language, so that they run on multiple platforms without having to build for each of the architectures of this. So that's what the CLR is. So that's what the .NET lays that bed. It lays that bed. So CLR, which is the Common Language Runtime, is Microsoft's own implementation of CLI. That's a common language infrastructure. So the common language infrastructure was actually an initiation of Microsoft. You know, so the common language infrastructure was originally, developed by Microsoft, but later standardized by standard organization like ISO and ECMA standard. You know, so like I said, it just to provide a common language infrastructure for multiple language to run on multiple platform without building specifically for each of the platforms. Okay, so moving on now let's see it, as a whole. We have the pictorial view of the .NET architecture. So now within the .NET we have multiple language. We have VB, we have C++, we have C#, we have JavaScript, etc. Now these are multiple language now. Okay, now all of them would want them to run within a common runtime. So it means that there has to be rule set. We have to set a rule that, okay, you guys have to abide by this rule. VB, you have to abide by this rule. C#, you have to abide by this rule. It's based on these rules that we would be able to run on a common language, or except otherwise this is not going to be possible. So the common language specifications details or contains the specification that each of this language must conform to. Each of them have to conform to those specifications within the common language specification, such that, or so that, it's easy for them to, while after compilation, they can run within, common language runtime. So when they say what is CLS, is pretty much like a database of specifications that each of these language have to conform to for them to be able to run within the common language runtime. So if you're building a VB, and your VB, you're using some, your build components with VB, you build a program with C#, you build all of this, all these, conform to the details within the CLS. So you can build all sorts of applications like web services, web forms, Windows forms, and all of that. You can build all of that there with all sort of applications, and these applications can be so complex that they have database access. They are accessing databases, exposing the database in any form that you like, maybe XML form, JSON form. You are doing authorization, you are doing authentication, you're doing login, you are doing all sort of stuff here. So it can be so complex. And then all these functionalities that you do, there's what we call the framework class library. The framework class library essentially details or contains the namespaces and classes objects that we have used while building the program. So if you are looking for, let's say you're looking for all the namespaces that have been used within this program, where are you going to find them? You'll find them within the framework class library. So the framework class library is much like a database of all the namespaces that have been used and other objects that have been used during the program. And of course, we say on top of this is where we then have the common language runtime. But first, you have to confirm with what we have within the common language specification. So that is the foundation. So this is a bit of what .NET architecture looks like at the surface. Now moving on now, C# types and variables. So any programming language at all, everything comes down to data. Is data, we are processing data, storing data, exposing data in any form that we deem fit. All right, so now in C# we need to we need to categorize the types, the value types, the type of data that we work with, how we reference the data, how we save the data, and how we reference data, of course. So the types are value types and the reference type. There are two types, value types and reference types. Now, so taking them one after the other. So the value types is further divided into the simple types, the enum type, the struct type, nullable types, and the tuple types. Simple types, enum type, struct type, nullable type, and tuple type. So let's see each of them one after the other. So the simple types is further divided into all of these. We have the signed integrals, and we have the unsigned integrals, we have the Unicode characters, we have IEEE floating points, and then we have the high decimal floating point, high precision decimal floating point, and then we have the Boolean type. So all these ones are just examples of each of these. So we have the signed integrals, unsigned integrals, Unicode characters, floating points, numbers, decimals, and Boolean. So example of signed integrals are S bytes, short, int, and long. So we are going to be seeing further examples of illustration of each of these as we move along. So we have that, and then unsigned integrals, bytes, unsigned shorts, unsigned int, and unsigned long. So if you don't know what's the difference between signed integral and unsigned integral, so the bit of differences that exists between them is that while in signed integrals, positive and negative values are possible. You can have -4, you can have +4, like that within the sign. That's why you can see sign byte, sign short, and all of that. And then in an unsigned integral, we only have positive values. Negative values is not possible. so that's why it's not signed. And then so here you have the Unicode characters, the normal 16 bit Unicode character, and then you have your floating point numbers, so the floats and doubles, and then you have your decimal points, you have your decimal, and then we have the bool, which is the true and false. So let me just elaborate a bit before we move on the floating points, and doubles. So the single floating point is a 32-bit floating point numbers, and then the double is a 64-bit floating point number, and then the decimal is 128-bit floating point number. So this is a floating point number, this is a floating point number, but float is 32-bit, double is 64-bit, and decimal is 128-bit. So the implication of this is that the decimal has higher precision. This decimal has higher precision compared to double and float, right? And then if you have double has, compared to float as well. And then we have the boolean, which is the binaries here. So we have the true or false in the boolean part. So these are simple types, value type. Moving on now. So we have the enumeration. Enumeration type is also another value type. So, or simply called enum. So these are three series of keywords, constants. These constants are unchangeable during runtime, so you can go and change from. In this case, the example we have here is basic, intermediate, advanced. We just create an enumeration, so we have basic, intermediate, and advanced. So you can have another example, let's say day of the week, Monday, Tuesday, Wednesday, and all of that. You want to use it somewhere, maybe on it for a drop down, for whatever it is. It's just a constant that is not going to change. So you can just define it. So and you define it by using a keyword called enum, and then you put your own name. So in this case, I just used level. So this is the enum keyword, and then you have the level. That's the name of this enum now. And then we have, these are just values, constants that we have in there. Don't forget, it's unchangeable. It's a read-only kind of variables that you assign within the enums, and it's pretty useful. You find yourself using it a lot, and then we'll see a lot of use cases. I've just mentioned one. Let's say you are exposing some sort of constant that the front end will be used as a drop down, or some sort of constants that you want to manage them centrally instead of having to code them everywhere. You just want to have a central place where they are kept. So if you need to change them, you go and change them from that central place. So there are a couple of use cases that you can find for it. So a numerical value is automatically assigned for it, like 0, 1, 2, and then you can override that by assigning the value to it yourself. So we see a bit of it. By the time we start coding, things should be a lot clearer. So this is an enumeration. So another thing that we need to know under the enum is that here we have this value, like this basic, intermediate, advanced. These are examples. You cannot have an implementation, a functionality is how we are going to use this basic within the enum. So there's something that we call method. If you don't know it, if you know it, you can relate. So there's something that we call method, which is an implementation of a bit of the variables and all of these things that you have defined. So you can have implementation of functionality here. You can have it within an enum. All right. So you should know that. Now moving on. Now we have a struct. A struct is a value type that represents data structure. So it encapsulates data and related functionalities. Unlike enum, this one you have the data and related functionality. Unlike enum. So, and you declare a struct by using a struct keyword as well, and then you put a name of your choice. In this case, the name of my choice is coordinate. So don't worry too much about public here. So I'm going to introduce us to it later on. This public you're seeing here is what we call access modifier. It's a bit of thing that tells your program how to treat these structs in this case. Whether it's a public material, is a private material, maybe it's protected and all of that. So this is just how, it's telling your program how to treat it. So later on you'll see how we would this is going to become clearer. So don't worry too much about whether we're using public and all of that now. So in this case, this one is going to be public, and you can see the word there, public. So but what I wanted to point out the attention tonight is just we're just talking about struct. So struct keyword and then the name of the struct. So within it you can have all this variable. Don't worry yourself about this, like I said. So this one is a variable X and is of type double, and then you have what we call a constructor here. So this is a constructor of these structs here, and implementing this variable. So another thing that is worth noting in struct is that one, it encapsulates data and related functionality. So if you're preparing for an interview, you have a job interview, and you're preparing, you can have to know some of these theories, because you never know who is interviewing you. So here a struct cannot have a parameterless constructor. A struct cannot have a parameterless constructor. All right. So why it's able to encapsulate data and related functionality, you cannot come and declare a constructor that is not using any variable. You can see this one using WX and WS. You can't just open it and close it. This is a bit of difference. This is what differentiates structs in at the surface from a class. They are pretty similar. So let me go back there. They are pretty similar, but a class can have a parameterless constructor, but structs cannot. All right, so moving on now. So we have what we call the nullable type. This is another value type. So this enables assignment of null values to value types. So when you declare a value type, say like integer, then you want to make it nullable. So when you say something is nullable, it's pretty like it's not compulsory. It can be null. All right, so initially you want to assign a null value to that value. So you declare, in this example we have age as our variable, and then we have this nullable type. This is how it's used. We just have nullable. Then you have in the angle bracket you have the type of this age, which is int in this case. So now we are making nullable. How we call this in C# is we make this nullable generic. So generic in the sense that it's typed. So in this angle brackets you then put the type here. So int, which is the age, is the name of this variable now, and then we assign a null value to it. All right, we'll assign a null value. In a nutshell, nullable type allows assignment of null value to value type. So this is how it's used. You see us using it when we get into the part where we start writing a lot of codes. Now we have what we call the tuple types as well. Tuple type is not available in all C# versions. It's only available from C# 7 and above. So the tuple type provides a flexible way to group data of different types. So if you have worked with array before, you know that array is a data of the same type, and of course array is belongs in other category of values of types. Is not in the value types. Now so tuple is pretty handy, and you see us using it a whole lot. So in this case here you can see that we have a double, and then we have an int. So we just declare how many we have here. We have two values. The first one is going to be double, and the second one is an integer. So we tell this, we create this ahead, and then the name of our variable is t1, and then equals to, then we have the values here. So I can have access to this for this first value by saying just t1.item1 would produce 4.5, and then T1 dot item 2 will produce 3. So by the way, I'm not sure I broke down the value type, properly. Value type, when we ask you what is even a value type, the value type saves its value directly. It directly contains its data. So when you save, you're saving directly to it. So in this case, I can just say T1 dot item 1, and it gives me 4.5, and then say T1 dot item 2, then it gives me 3, like that. So if I have more, I just command separate the type, and then I assign the value there. Now the reference type, this is the opposite of the value type. Now, unlike a value type, a reference type does not save the value directly. It saves the reference to the value. It's like you having the address of your bank. It's not saving where you are actually saving the money. So this one is just a pointer to the memory location, not to the value. A pointer to the memory location, not to the value itself. So that is a reference type. You need to be very clear about that if you are going to be writing exam, or if you are going to be attending interviews. Beyond that, it's also very important for for you to be well grounded in this language, and even other language as well. So in other words, a reference type contains a pointer to another memory location. So moving on now, let's look at the various reference type that we've got. So we have the class type, we have the interface types, we have the array types, and we have the delegate types. So looking at the various class type, the first one you'll see there is the object, which is the base of all types, objects. So when we're defining C#, we say C# is object oriented, component oriented, and type safe programming language. Now, so what you need to know is that object is the base of all classes. So the class types is a reference type. So this is an example of it. And then you have a string, a Unicode string, which is also belongs into the class category. And then user defined type. So you define your class by just using a class keyword, and then you put the name of the class there, and then you open a brace for the implementation of the class. So pretty much you see us using, in fact, from the word go, you see us using the class a whole lot. So we'll break it down further by the time we start writing the codes. And then we have an interface. Interface types are pretty user defined, and then interface is pretty much a contract that could be implemented by class types or by an enum type. So any class or a struct that has implemented an interface must implement all its members. So it's pretty much a contract. It's a binding contract that is saying that, okay, yeah, we are entering into an agreement. So when you enter into agreement, you have to fulfill the agreement by implementing all the member of the interface. You'll see what we are talking about by this time we're getting our hands. So if it's not so clear now, don't worry too much. Now we have the array types. So array is pretty much an object of the same type as far as it's concerned. So we're not talking about the basic array in JavaScript. Here we are talking about, say, like we have an arrays of teachers, arrays of students, arrays of developers, arrays of computers. When I say arrays of computers, all the items here are computers, so they are items of the same type. Arrays of professors, these are objects of the same types. Now, so we have different types of array. We have the single dimensional, we have the multi-dimensional, and we have the jagged array. We see all of these by this time we start getting our hands dirty. And then we have what we call the delegate type. So delegate is pretty much a pointer to a memory location. That's a bit of what a delegate is. Um, a pointer to a method, I meant to say. So a delegate is known in C and C++ as a function pointer. Is known as a function pointer in C and C++. And then a delegate could be a single delegate, it could be a multicast delegate, and it could be a generic delegate. So pretty much a delegate is user defined. You define your delegate, and then you define it by using a delegate keyword, and then you follow it by the expected return type of the delegate, and then you put the delegate name, and then the delegate name and the open brace and close brace, like that, for the implementation of that delegate. So this is a bit at the surface of reference types. So again, reference types are class types, interface types, array types, and delegate types. Reference type, remember, saves the pointer to the memory location. Is a pointer to the memory location, not to the value itself. Okay. Now, C# as a programming language has a lot of keywords. And you have seen us use them, like class is a keyword, struct is a keyword, if statement is a keyword. You see us using while statement, for statement, and all of those things. These are various keywords. So keywords have specific meaning to C# engine. So you don't use them because the way compiler interprets it, has a special meaning to it. So as much as possible, do away with it, run away from it. But if you must use it, please, you have to prefix it with an @ sign. @ So you use @ to prefix your that keyword. So by the time you use that, it's not going to be interpreted as a keyword any longer. So, and then it will be ignored. So if you use this, for instance, in this example, we have @if. @if is a valid identifier. But if you use only if, it's not a valid identifier because it's a keyword, and then it will be interpreted in a way that the compiler knows it as. So for a complete list of C# keywords, if you want to see where they live, you can go to this documentation, doc.microsoft.com, and then all these links, you just open it. So you have all the C# keywords. So these keywords will be in links. It will have is a link. So if you click on it, if you want to know more about any of the keywords, click on it. You see the description of it and how it can be used. So that will encourage you to check it up to see what we are talking about. So now that we have introduced ourselves to the basic theories, laid the foundation, and I think it's time to write some code. Let's code, guys.